Okay, this time factorising quadratics via dots, otherwise known as dots. So, what is dots? Difference of two squares. Sometimes it's called dots because they change out 2 for perfect, but that's a bit more of a niche case. I prefer dots. It's also easier to say. So, what are we talking about with dots? Well, difference of two squares. Difference, minus sign, 2 squares. So that's a square number, there's a square number. Or in other words, 5 squared minus 4 squared. So this is the sort of thing that we're talking about. Okay, now that seems a bit weird because here's I've all got perfect numbers. I already know what the result of this is going to be. That's not difficult. That's just so that you know what I'm talking about where the name dots comes from. We don't particularly care about these nice easy things. What we care about is all of this garbage. Well, let's think about this for a second. Can I factorise this currently? No. Left it at the end of the last one. Alright, well, I'm going to give you a massive head start and just say, expand this and see what happens. Okay, well, x by x gives me x squared. I forget which colours I did this last time, so minus ax gives me positive ax, gives me positive a times negative a squared. Cool. Can I simplify that down? Well, yeah, I definitely can. Still got an x squared. These two, minus ax and plus ax, they're going to kill each other. So they're gone, but I've still got this minus ax. Make sure they're on purple. Cool. What did we end up with? Oh, well, look at that. We ended up with the difference of 2 square numbers. Okay, brilliant. So what? Well, that means that whenever we see something like this, we can change it back to that because we know that this will expand to that. So, what does that mean for us? That means that we could change, since we know this goes to this, we could change this into, this is going to be my first number, so x's, so I get open bracket, open bracket, open bracket, open bracket, 5 and 5, plus and minus, second number, 4 and 4. Brilliant, so I get 9 and 1 equals 9. Well, that's a whole lot of good because I could have just done 25 minus 16, well that's 9, well done, what a waste of time. But this isn't supposed to make those easy numbers so much faster. It's supposed to make either ridiculously big ones of these where you can recognise all these are squares, which isn't going to happen too often. But more importantly, it's to help us with the algebra. Okay, so I've got this. Great, I've got a squared x and a 9. Well, I know that 9 is 3 squared. So I've got 2 squares with a difference. Great. So this is like that, so I can switch it back to this form. X plus the other number, x minus the other number. Beautiful. And you can expand it out to check that it all works. X by x squared, negative 3x, positive 3x, negative 9. The single x's cancel, so I end up back at x squared minus 9. Beautiful. Down here, well, I can rewrite that as 64 is 8 squared. Cool. So first number plus second, first number minus second. Beautiful. What about this guy? Oh, hang on, now I've got more things floating around. Oh, well, hang on a second. 4 is also a square number. So I've got 2 squared multiplied by x squared minus, that's 9 squared rather. Whoops. Cool. Well, hang on, we've done index laws before. We've got 2 squared and x squared. Well, why don't we just write the squared once? So this is 2x all squared minus 9 squared. Oh, cool. So I can treat this whole thing as one number. So I've got the first number, 2x, plus the second number, and first number, 2x, minus the second number. And again, expand out, you'll end up back where you started. That's how you know you're on the right track. Beautiful. Well, okay, can we simplify this thing? Well, yes, we most certainly can, and we can do this progressively faster, but 5 squared and x squared minus 6 squared. All of these are squared, so I'm going to get the first number is 5x, second number is 6, 5x minus 6. Beautiful. Okay, this guy. Well, hang on. 7, that's not a square number. I'm having a bad time now. Crap. Well, remember, we always said go back to the start of your list of the ways you know how to factorise. We knew how to do this before. This is grouping. This is common. What's in common here? 7 and 28. Oh, I can take out a 7 before I even start. I can take out the worst bit. Okay, oh, brilliant. I know how to do this bit, so this is just going to sit out the front. 7, open. first number plus second number. By the way, that's 2 squared. Cool. First number minus second number. Beautiful. Okay, well, I've got this. Well, I've got non-square numbers, that's looking a bit annoying, but 20 and 5, they both divide by 5. So this is 4 minus x squared. Okay, oh, well, hang on, the x is on the other side. Well, does that really matter? No, because we've just been treating this as a number anyway. So it's a number and a number, now it's a number and a number. Doesn't make much difference. Just the order changes around. Okay, so the first number is now 2 plus x. Second number, 2 minus x. There we go. Beautiful. Incidentally, you can, if you want, write this as 5x plus 2, and then negative x plus 2 if you want. This is getting a little bit weird though. You could also, if you wanted, take out that negative out to the front, so you've got negative 5x plus 2, and then x minus 2. All of these are equivalent. I'm going to suggest that you stick with that for now, but just so you know for future reference, if it comes up or if the answers are slightly different to yours, if you can expand yours and get back to where you started, you know yours is okay. If yours doesn't exactly match, you might want to just check for if they've moved the negative around. Cool. Okay, next bit. X squared minus 7. Oh, well that's not a square, but that's alright. I'll just take out a common... Oh, there is nothing in common. Bother. Well, this is where we can start playing fiddly bits with it, and we can say, well that's fine, that's x squared. What squares to 7? Well, I can cheat a bit here and say, well, the square root of 7 squares to 7, and that's fine, because that's still a number. And remember, all we were dealing with was just a number. Okay, so first number, x, plus second number, square root of 7, first number minus second number. Beautiful, and that'll still work just fine. Cool, similar idea, okay, this is x squared minus the square root of 3 squared. Cool, first number plus second number, first number minus second number. Great, easy. Okay, I've got this, alright, so I should take the square root of this. Well, you could, or you could just go, well, hang on, I've got a 4 and an 8. I could take out a common factor, and that would make life a bit easier for you. For a little bit, minus 2, beautiful. Oh, hang on. This isn't a square number, that's okay, I'm back to this. I just have to keep the 4 out the front. First number minus second number, remember we've got to take the square root of this thing. Sorry, plus there, and then minus there. Now it doesn't matter if I make this one minus, that one plus, no, but one's plus, one's minus. Beautiful. This thing, oh, now I've got a whole lot of stuff going on. Well remember, this whole thing is just one number. We don't know what x plus 3 is, but it's a number. So we can just treat this all as one number, okay? So we've got this number squared minus this number squared. Brilliant. First number is all of this, x plus 3, plus second number, 4, x plus 3, first number, minus second number, excuse me. Cool, well this time we can actually simplify, we can go a bit further because we know that's 7. And we know that's minus 1. Excuse me. Cool. Next one up, we've got this. Okay, well, we could take out a common. We could take out a common 9. And then we can go similar to this. We could take 9, x plus root 2, x minus root 2. Brilliant. That's one way of doing it. Alternately, you might have gone, oh, hang on, this is a square number. So I could say that's 3 squared x squared minus the square root of 18 squared. Okay, yeah, you could do that. So we'd have 3x plus root 18 and 3x minus root 18. Well, hold on there, these things don't look the same. And this is why it's usually a good idea to try and take out commons first, because this is a lot neater than this guy, even though they are equivalent. The way we get to equivalence is by doing a bit of surd work. This has a factor of 9, so this is 3 root 2 minus 3 root 2. Great, all of these have a 3 in common, so I take that out the front. And all of these have another 3 in common, so I'm taking out 2 lots of 3 and then multiplying, so I end up with 9 lots of that. Beautiful, and now we're back to where we started there. So, always try to do common first, because it almost always makes life easier for you. Okay, what about this? Well, hang on, now we don't even add any numbers, but x's and y's are just representing unknown numbers. So that's fine. We're just taking first number plus second number, first number minus second number. Done. Beautiful. These guys, well, that's the same as 2 squared x squared minus 3 squared y squared. Okay, well, that's going to be first number, 2x plus second number, first number minus second number. Beautiful. Alright, well, this is getting a bit chunky, boy, but it's still the same idea. Alright, well, that's just going to be the square root of 12 squared with x minus 5 squared minus 2 squared with y plus 7 squared. Cool, the first number is all of these put together, which will tidy up this third. So what do we get? We get 2 root 3. Cool, multiplying by x minus 5. So that's my first number, plus my second number, 2 lots of y plus 7. So that's my first bracket. Second bracket, have I got enough brackets in there? No, there. So just to be clear, these brackets are those ones. Cool. Then first number again, 2 root 3 multiplied by x minus 5 minus second number, open bracket, 2, oh, did I have an open bracket here? Oh, you don't need it. Come on. This is just 2 times. X plus 7, close bracket. So that set of brackets is that one and that one. Cool. Now, did that actually make it better? Well, this actually got a lot longer, so it actually looks a lot worse. So you might opt to just keep that in that form when you're doing just general work. However, we can take things and write them in totally different forms. Sometimes that will make life easier. Even though it's a longer line, it might actually be more useful to us. But for now, we're just practicing the skill. Okay, well, what about this thing? Well, that looks nice and easy, but hang on, that's got a plus. Well, that's a problem, because our method is the difference of 2 squares, not the sum of 2 squares. So if you've got a plus, you're a bit stuffed, even though it's nice and simple. There's nothing in common there, so that one's stuck where it is. So we can't do anything with that until we get into complex numbers, which unless you're doing spec, you're probably not going to see. Alright, well, that's about all we've got for this. So all I want you to remember is whenever you see a square minus a square, or whenever you see a square involved with a minus, dots should cross your mind. Cool. You've got the practice on the sheet. Best of luck to you. Email me as always. Cheerio.